In this video, we're looking at how to differentiate a function when that function is a product of two functions. Now, what do I mean by that? Basically, we're looking at a function, let's say f of x, and it is a product of the function u of x and v of x, just like that. So if this is the case, then basically your derivative of this whole thing is going to be the following. It's going to be u dash x, or the derivative of u of x, times the original function v of x plus the original function u of x times the derivative of v of x. And we're going to do an example of how this works in a minute. But for now, what I want you to accept is that this thing over here in this red box is going to be the differentiation formula that we're going to be using. Okay, so let's take a look at an example, and we're going to use an example that you don't necessarily need to use the product rule for, but I just want to show you that it works using the traditional way of differentiating and this new way as well, and we should get the same result. So what we're going to do is we're going to look at an example. We're going to look at an example, and our example is that we have some function of x, and it is defined as 2x squared times 3x minus 7. Okay, so now you can see, hopefully, that, well, this is a function that is the product of two functions, where this thing over here is one function, and this is going to be our u of x. Okay, so this thing over here is going to be our u of x, and this thing over here is going to be our v of x. Okay, so let's try this using our original method first, because you can see that at this stage you could really just expand the brackets and then differentiate how you normally would, right? So let's see how this turns out first. So we've got our original function here. If you expand the function, you get 2x squared times 3x. That'll give you 6x cubed. 2x squared times negative 7 gives you negative 14x squared, like that. And now finding the derivative, df dx, is going to be 18x squared minus 28x, like that. So that's not too bad. Now, we're going to do the same thing, but we're going to be using the product rule to do this. So in our case, here at the moment, our u of x is equal to 2x squared, and our v of x is going to be 3x minus 7. Now, if you look over here in the differentiation formula, then you can see that we're going to need to find the derivative of u of x, and we're going to need to find the derivative of v of x. So let's go ahead and do that. The derivatives are going to be given by u dash of x equals to what? Equals to 4x, right? And the derivative of v of x, v dash of x, is going to be equal to 3x minus 7 differentiated just becomes the constant 3, right? So now let's put it all together. We've got f dash of x, or df dx, let's say. We've got df dx equals to what? Equals to our derivative of u of x. That was 4x, if you recall. So 4x times what? Times our original function v of x. Our original function v of x was this one here, so that's times 3x minus 7. Now we've got plus u of x plus our original function u of x, that's 2x squared, times the derivative of v of x, that was just 3, so this is just times 3. Okay, I mean, at the end of the day, really we're done at this point, but we can't just leave it like this. We need to tidy it up a little bit, right? So let's tidy this up. By that I mean just simplify the whole thing. So we get 4x times 3x, that'll give us 12x squared. 4x minus times negative 7 gives us negative 28x. 28x. And then here we've got plus 2 times 3, that's 6, so plus 6x squared. Okay, and we can once again tidy this up a little bit. We've got 12x squared plus 6x squared. Well, that'll give us 18x squared minus 28x. And hopefully now you can see that even though this was written a slightly different way over here, that in the end, this one here and this one here are exactly the same derivative. Okay, that's all good and fine. Let's try the same idea on a question where the derivative is not quite so straightforward. So let's try another example. In this example, this one's going to be a little bit longer. So we've got some function, again, f of x, which is defined as 2x minus 7 raised to the power 5. And this, all of the stuff we're multiplying by x minus 6 raised to the power 3. And I encourage you to pause the video here to just try and solve this one yourselves. And if you have an answer, or you think you have an answer, then you can resume the video. Okay, so I assume that you've had a crack at solving this question yourselves first. So as you can see, again, we've got the product of a function here again, right? Where you can define this part over here as u of x. You can define all of this business here as v of x. And then once again, our derivative of this function is just going to be, just like we had on the previous page, we have f dash of x, or df dx, is going to be u dash of x, the derivative of u, times the original function v of x, plus u of x times v dash of x. So all we really need to do is find the derivatives of u and v, and then we're home free. So let's define our function u of x. U of x here was 2x minus 7 raised to the power 5. Okay, we need to find the derivative of this. And to do this, you'll notice that we'll need to use the chain rule once again. So really, this is a combination of two things, the chain rule and the product rule. So we've got, so we need to find du dx first. Du dx. Well, how are we going to find that? We're going to need to define something in here as another variable. Let's define what's in the brackets here as our value a. So then this whole thing becomes du dA times dA dx, just like that. And then we're going to let a equal to the thing in brackets. So that's, so that's, let me just get that back to the original size. Let a equal to 2x minus 7. In that case, dA dx is going to be just 2. Cool. That means our original function u of x is equal to a to the power 5. So then du dA is going to be 5a to the power 4, which is, of course, 5 times whatever a was, 2x minus 7, raised to the power 4, like that. And therefore, we can take now this part here and this part here. So then therefore, du dx equals to what? Equals to 2 times du dA, which is 5 times the thing in brackets, 2x minus 7 to the power 4, which we can simplify to give 10 times 2x minus 7 to the power 4. Okay, that's half of it done. Now let's do the other half. We need to find the derivative of v of x. V of x, remember, was all of this business here. So that's equal to x minus 6 raised to the power 3. Again, we're going to need to use the chain rule here. I mean, you could expand this out, but we can save ourselves a lot of work if we don't. So we're going to say let a equal to x minus 6. In that case, dA dx is equal to 1. If that's the case, then our function v equals to a cubed. Means dv dA is equal to 3a squared, which is equal to 3 times our original function a, x minus 6 squared. And now we can find dv dx as dv dA times dA dx. So 3 x minus 6 squared times 1, and we're just multiplying it by 1, so that doesn't change it. Minus 6 squared, like that. And now we can finally answer the question. The question was to differentiate this stuff here. So that's the derivative of u times the original function v plus the original function u times the derivative of v. So now we can say, therefore, df dx is equal to the derivative of u with respect to x. That's 10 times 2x minus 7 times the original function v, which was, oh sorry, I forgot my exponent here, times the original function v, which was x minus 6 cubed, x minus 6 cubed, plus my original function u, which was 2x minus 7 to the power 5, 2x minus 7 to the power 5, and I'm starting to run out of room here, times my derivative of v with respect to x. So that's times 3, let me just bring this down just a little bit, bring this down. Just a little bit over here. So 3 times x minus 6 to the power 2. And of course, technically, we're done at this point, but let's just tidy it up a little bit. Just a little bit. So this whole thing becomes 10 times 2x minus 7 to the power 4 times x minus 6 cubed plus 3 times 2x minus 7 to the power 5 times x minus 6 squared. Okay, squared, like that. And we're done. That's the derivative of the original function that I showed you earlier.